All right, so now let's go ahead and go over part C4. So we're going to rewrite this quadratic into a perfect square, and then we're going to solve for x. So we have 24 x's here. We can split them into two parts. So 12, half of them go over here. The other half are going to go over here. And notice that we're going to have a 12 by 12 square, 12 width, 12 height. So we know that 12 by 12 section needs 144 units. We only have 129, so we need a few more. I think if we add 15 more to both sides, do you see how we end up with our 144? And we want 144 here, so that 12 times 12 equals 144. So now that we completed our square, let's go ahead and factor x minus 12, x minus 12. And notice that all the parts of our factor works. X times x is x squared. X times negative 12 is negative 12x. And negative 12 times negative 12 is positive 144. So now that we have the same base times height, we can write it as a perfect square, x minus 12 squared. And what's nice about this is, again, we can square root both sides. So square root both sides. Okay. Let's copy and paste. Notice that the square and square root are going to cancel out, leaving me with x minus 12. And here, square root of 15. Square root of 15 doesn't have a nice number. And if I do square root of 15, it's going to be a irrational number, 3.8729. So we're just going to leave this as a perfect square. We're going to leave it as square root of 15. And we know there are two versions of this answer, either positive root 15, and negative root 15. So to solve for x, we can plus 12 on both sides. 15 plus 12. And we can plus 12 to the other side. Negative root 15 plus 12. Oops. Plus 12. All right. So those are our two versions of the answer, using either the positive root 15 or the negative root 15. Okay. Let's answer the focus question. How can we generalize the process for completing the square? We can split the x in half. X in half. So the base and height are the same size. Right. From there, we can see how many more tiles we need for the missing section. And then we can factor into a perfect square, which lets us square root both sides, or something like that. Again, if you want to summarize this answer, you guys can. Again, I tend to be a little bit wordy when I type out my answers. All right, so the next 5 pages are going to be practice problems. You should try it on your own, but if you need help, I'll go ahead and go over these now. But again, highly recommend that you guys try these on your own first. Okay, so let's see, x squared plus 4x equals negative 3. Again, if I split up 4x, I know half of it goes here and half of it goes here. We have a 2 by 2 box, So I need 4 areas to fit inside here for that 2 by 2 box. So I need 4 more areas. And notice by adding 4 on both sides, negative 3 plus 4 is now 1. And now this is a perfect square with x plus 2 on one side and x plus 2 on the other side. Now that I have x plus 2 by x plus 2, I can write this as a perfect square, x plus 2 squared. And the answer is going to be two versions, x plus 2 equals root 1, or x plus 2 equals negative root 1. What's nice about square root of 1? I know that 1 times itself is going to be 1. And I know that negative 1 times itself is also going to be 1. All right, we have a negative and a positive version of the answers. So from here, to solve for x, we can minus 2 on both sides. X equals negative 1. And here with minus 2 on both sides, let's see, a negative and 2 more negatives. That's going to be negative 3. All right, moving on to the next. Here we're another completing the square. Again, negative 8x, half of it goes here. The other half goes here. All right, and we're going to have a 4 by 4 section. How many unit tiles are we going to need? So again, for a 4 by 4 section, we're going to need 16. 4 times 4 is 16. But we only have 7 so far. So we're going to add 9 to both sides, plus 9 on both sides. So 7 plus 9 equals 16, and that's how much we need to fill in the gap. And 0 plus 9 is 9 on the right-hand side. Now we can factor this out into a perfect square. So x minus 4 times itself is x minus 4 squared. And what's nice about the perfect square is that we can now square root both sides. Oops, square root 9 in here. Again, square and square root, those cancel out, which is why we're only left with x minus 4. And square root of 9 has two versions. It can either be 3 times 3 is 9, or negative 3 times 3 is 9. Okay. So now that we split up our answers into the positive and negative version, we can add plus 4 to both sides. Plus 4, 3 cancel out with 4 is going to be 1. So those are our two answers. All right. I think we have one more completing the square and then two more just regular factoring problems. Let's see. How many more units do we need to complete the square? Here we have 5x. Even though this is an odd number, we can still split it in half, right? It's going to involve decimals, but we can still split it in half. Half goes here, half goes there. I know this completed square for a 2.5 by a 2.5. Let's see. 2.5 by 2.5. That's going to need 6.25, and we have negative 2. So we actually need to add 8.25 more. So again, the negative 2 is going to cancel out with 8, leaving me with 6. So I'm going to add 8.25 to both sides. X plus 2.5, x plus 2.5. And since we have the same base times height, notice that we wrote it as a perfect square, x plus 2.5 squared. So now we can square root both sides. Equals square root of 8.25. I think 8.25 doesn't have a nice square root. Let's check. Yeah, it's going to be an irrational number. So let's leave it as a perfect square. And then from here, we're going to minus 2.5 on both sides. Minus 2.5. All right, same thing over here. Again, the negative version, because the negative times itself is going to be 8.25. And I'm going to minus 2.5 on both sides. 0.25, whoops, minus 2.5. All right. The next two problems are going to be factoring. So again, not necessarily completing the square, but again, we should still be able to factor and solve it when x equals 0. So for here, what's the equation? Let's write this as a product. You could use the diamond problem and factor it out if you want. You can use these tabs here, but this is going to be optional. Let's just go ahead and think about it. Let's see, I know that x times x is x squared. How can I get 40? Let's see, 2 times 20. Let's go with 10 and 4. Notice that this answer is negative, so I need one of these terms to be negative. And I think I'm going to make the 4 negative. So I know that 10 times negative 4 is negative 40. 10 times x is 10 squared, negative 4x. And then 10x and negative 4x cancel out to get 6x. So how can I solve this? Again, I need to set what number makes the left part 0. I know that negative 10 is going to make the left part 0. And if I plug in negative 10, this turns to 0. And the whole thing will be 0. How do I turn the right part to 0? So if I plug in 4, 4 minus 4 turns to 0. And then the whole thing ends up being 0. So those are my two answers. Well, one last problem. Here I think I will use the diamond problem. This one's a little bit complicated to factor out. So let's see. 2 times negative 24 is going to be negative 48x squared. All right, I know they need to combine to 13x. So what two numbers multiply to 48? I know, let's see. 8 times 6. No, that's not going to be it. 12 times 3. Closer. I think it's going to be 16 times 4. 16 times 3. So I know 16 times 3 is going to be 48x. And I want one of these to be negative, so I'm going to make the 3x negative. So notice that 16 times negative 3 is going to be negative 48. And 16 cancel out with 3 would be 13. All right, it completes my diamond problem. So now that I have 16 and negative 3 in the right spots, I can factor. Let's see, I can pull out 2x from 2x and 16. I can pull out an x here. 2x times x is 2x squared. And 2 times what equals 16? I can put a plus 8 here. 2x times 8 is 16. And I can put a minus 3 here. So x times negative 3 is negative 3x. And negative 3 times 8 is the negative 24 that we want here. So factoring it out, we have 2x minus 3 and x plus 8 equals 0. Oops, x plus 8. All right, from here we can go ahead and solve. Again, I need to turn the left part to 0 to turn the whole thing to 0. So 2x minus 3 has to equal 0. Once that's 0, the whole thing is going to be 0. Let's see, plus 3 to both sides. Divided by 2 on both sides. So x equals 3 over 2. Right, and here I can see if I plug in -8, it's going to turn the right half to 0. So x is going to be -8. So those are going to be our practice problems. If you guys still have questions, please let me know. And I hope you found this video helpful.